All right, so we're going to look at population versus sample. And before we get into the real definitions, I'm going to give you a little bit of an example using our class. And so I know that I'm not there with you. This is a video right now. So I'm going to kind of make up some of my stats. Let's say that today we have 30 students in class. And I know a lot of us are getting ready to drive. We're turning 16. So we're going to pretend we know how many students in our class have turned 16. And so let's say I went around, I asked each of you how old you are, and 12 out of 30 said, yes, I have turned 16. So 12 out of 30, that's kind of like a ratio, right? That's how many we have out of the total. I could turn that to a percent if I do 12 out of 30 is the same as 12 over 30. I get the decimal 0.4, which tells me that 40% of the sophomores in our class are at least 16. So, there we go. I've just surveyed everybody in the class. I've found out your ages. I've found the percentage of sophomores in our class that are at least 16. Do you think then it's reasonable to estimate that the same percentage of Dacula High School sophomores have turned 16? So if I want to look at the entire sophomore class, do you think about 40% of you have already turned 16? How close do you think this is to the actual percentage of sophomores? I changed it for us. Well, this is a good example of population versus sample. So here I want to know what percentage of Dacula High School sophomores have turned 16. My population is the entire Dacula High School sophomore class. But it would take a long time for me to go around and ask every single sophomore how old they are. Instead, it's a lot easier to take a small sample. And so you guys, my class, are my sample. I ask you how many of you have turned 16. And then we can kind of generalize for the whole population. So that is the difference between a population and the sample. And so we have different statistics for each. And the first one here we're going to talk about is parameter versus statistic. And the parameter, this vocab word, means a measure of the entire population. Versus a statistic is a measure of the sample. So in our example above, we weren't sure about the parameter. We don't know the actual number of how many sophomores are already 16 in the whole class. What we did know is the statistic for our class. We know that in our class, 12 out of 13 sophomores have turned 16. Now we also have these new symbols here. You might have seen them before, maybe not. This one right here that goes along with the parameter is what we call the population mean. So if you remember, the mean is like the average, right? And so the population mean would tell me the average of the entire population. Whereas this other symbol, which is X bar, it's X with the bar on top, this is what we call the sample mean. And again, this would be the average, but only looking at our smaller sample. All right, so let's kind of look at some examples here that deal with these different vocabulary terms. The first one says, the average salary for everyone in the state of Georgia is $59,106. When a random sample of 100 people in Georgia was taken, they found the average salary to be $65,227. Identify the following. So, in this example, the population is everyone in the state of Georgia, because it says that we start with everyone in the state of Georgia. That's what we want to know, the average population for our average salary for everyone. My sample, though, is only 100 people in Georgia. We didn't actually survey everyone. We just asked 100 people out of everyone. Now, what was the parameter? Remember, the parameter is the measure of the entire population. So the entire population's average salary was $59,106. The statistic is for just the sample. So when we only looked at the sample of 100 people, we found their average salary was $65,227. All right, let's look at the next example. It says the average cost of attending a university in the U.S. is $25,620. When a random sample of 5,000 people who attended college was taken, the average cost of their college was $37,248. Identify the following. So in this one, we are looking at the average cost of attending a university in the U.S. So I'm looking at the population, which is universities in the U.S. So we're looking all over the United States, everyone in the United States. The sample is the 5,000 people who went to universities in the U.S. The parameter, remember, is a measure of the entire population. So the average for across the United States was $25,620. The average, when we just looked at our random sample, though, was $37,248. And so that is the statistic. All right, so we're going to look at two new symbols, P and what we call P hat. And so I guess P is not necessarily a new symbol. It's the letter P. But this P stands for, it's the probability, the proportion of our population, whereas P hat refers to the probability, the proportion of the sample. And so we are going to now talk about when would it be appropriate to use these two. And we've got some examples below. So on the left, it says about 30% of people in Georgia have a bachelor's degree or higher. When a random sample of 1,000 people in Georgia was taken, they found that 22% had a bachelor's degree or higher. Identify the following. So notice this problem. It talks about people in Georgia. That is our population. The sample that we took was only 1,000 people. So randomly 1,000 people were selected in Georgia. The parameter, remember the parameter talks about the population as a whole. Now in this one, we have those percentages. And so I'm going to use P here, talking about P. For the parameter for the population, it was 30%. I'm going to do 30%. But remember, percentages and decimals kind of go hand in hand, so it's good to remember 30%. That is 0.3 as a decimal. Then we're going to get to the statistic. So the statistic about just the sample, that would be P hat. And for this example, that was 22%, or as a decimal, 0.22. In the next example, it says the percentage of minority-owned law firms in Georgia is 40%, which is higher than the national average. Go Georgia. These are some real statistics, guys. When a random sample of 2,000 law firms in Georgia was taken, 34.8% of them were minority-owned. Identify the following. Take your time here and think about it. What is the population? We want to know law firms in Georgia. We are looking at all law firms in Georgia. Now, we want to see how many are minority owned, but my population is just all law firms in Georgia. The sample was taken from 2,000 law firms in Georgia. So instead of looking at everyone, we just sampled 2,000. The parameter, which is the information about the population as a whole here, we would use P because, again, we're talking about those percentages. P is 40%, or if you saw it as a decimal, 0.4. The statistic, so the percentage that we found from just our population, would be P hat here, and that is 34.8%, or 0.348. Now, remember above we had talked about parameter and statistics, but before we were looking at the average cost or the average salary. And so we were really using the means, the population mean and sample mean. So you could even go back here, and we didn't necessarily label them before, but definitely you might want to label them now. The parameter, that was our population mean. The statistic was our sample mean. Right, and so the difference was we were given the averages before. In these newer examples, we are given the percentages. So there's a difference in the data that we have collected here in both of these examples, or all four of these examples.